YouTube. This is a video in which I'm ultimately going to get at how to solve absolute value equations. But before we do that, let's go ahead and start by having a conversation over what absolute value is, or the idea of absolute value, what it represents. Okay, so we say the absolute value of a number is the measure of distance between that number and zero on the number line. So this is actually the formal definition of it. And the thing I want to point out here is the key word is distance. Okay, when we talk about distance, keep in mind, you can talk about, zero here, and we say 1, 2, 3, and I'll go ahead and put 3 on here. We're going to be talking about it anyways, and negative 3. But the thing I want to point out is this. We refer to 3 steps to the left, like if direction matters. I guess let's put it this way. If I were to go 3 to the left and direction matters, the left 3. Or if I were to go to the right 3 and direction matters, I could say positive 3. But what this is representing is displacement. Okay, and displacement is, in another word, kind of like directional distance, all right? And what we're talking about is distance. So the cool thing about distance is this. When you talk about distance, if I said how far away from 0 is negative 3, it's like, 3 steps away. And how far away from 0 is positive 3? It's like 3 units away, okay? So in other words, when you talk about absolute value, it's kind of a measure of distance back to 0, and distance is always positive. So, you may remember this from Algebra 1, evaluating absolute value. And the nice thing about it is you don't actually have to graph it to tell me that they're 3 units away from 0 in this first example, but you might remember that it just makes things positive is what you probably remember it as. At least that's how I did it when I was like in 7th grade. So let's think about this here. We say negative 7. What I'm really asking is how far away from 0 is negative 7? Well, it is 7 steps away. Okay. And what if I were to ask like 1,007, how far away from 0 is that? Well, it's 1,007 steps away. Absolute value is a really simple concept to work with. Now, do not get carried away with this idea that it makes everything on the inside positive, because it doesn't. As a matter of fact, when I look over here, it says negative 7 minus 4. When I say it doesn't, actually it does, but it doesn't. I mean this. It doesn't just take an expression like negative 7 minus 4 and then instantly convert it into this thing where this is a positive 7 now plus a positive 4. Because that's just fiction. And as a matter of fact, I in this case get the same thing, but the question is, in general, what would happen if I had something like this, a negative x plus y? Should I make this a positive x plus y? And the answer is no, not in general, not in general. So what we're going to do is we're going to avoid when we have an expression like this, like I could put parentheses around this. We are going to avoid doing absolute value to individual terms unless we can combine like terms, which in this case we can. So we would get this, actually. In this case, we'd say negative 7 minus 4 end bracket, and that is our absolute value there, by the way. And I say equals what? This is what I want to know here. The nice thing about this is we're going to treat it the same way we do parentheses. Now, I'm not saying, like if there were 2 out front, I could distribute the parentheses. I'm saying that we're going to do order of operations, so we're going to do what's on the inside first. So in this case, I get negative 7 minus 4. In this case, is negative 11, and we get positive 11 as our absolute value. But anyways, all that aside, we need to know what absolute value is, because I'm about to beg this question. What if I had a number sentence like this? I say x, the absolute value of it is equal to 8. We don't know what x is, but I do know this. It is 8 steps away from 0. So when you kind of visualize this on the number line here, I'm going to make it real easy for you. If you went 8 steps this way or you went 8 steps this way, 8, guess where you are going to land? You are going to land at negative 8, and you're going to land at 8. So basically, and we could check this. We could say, well, what's the absolute value of negative 8? I mean, does it equal 8? I'm just plugging it in here, and I get 8 as 8. So that's a valid situation. If I said the absolute value of 8 also equals 8. Well, of course, 8 equals 8. So these both check out. So here's the deal. On this very, very next sentence, you're going to notice it's a little bit different. We say, all right, what are the values of x that would cause this to be true? And again, we're saying, well, what numbers are negative 8 steps away from 0? And in this case, we'd say that there are no solutions. Okay, and this is one thing I just want to point out here. You're never going to be able to say that the absolute value of something was negative. And the reason why is because distances are never negative. They're non-negative. They could be 0, but they are non-negative ultimately. Okay. The interesting thing is this one. Let's look at this line right here. The fact is, when we wrote that the absolute value of x equaled 8, we got 2 solutions, and we were able to determine that x equals negative 8 and x equals positive 8, and we could certainly see those on the number line. We had drawn that right here. But the thing I want to point out is this. What we had done was we had actually isolated, first of all, believe it or not, the absolute value on the left-hand side. So the absolute value is all by itself, but we actually rewrote this statement, okay? And we did it two ways. We're going to call this first and the second one. How about I need to write a 2, okay? So here's our second case, and here's our first case. And what I want to do is I want to do a little compare and contrast with what I started with, okay? So this is the initial sentence. And so what I want us to notice is in both of these instances, we still have x on the left. This thing that was inside the absolute value bars, we kind of left it on the left there, but you'll notice that the absolute value bars, gone, okay? So we dropped them. We still have an equal sign, but in this case, I want you to notice that 8, we rewrote it. And in each instance, the first one, we rewrote this as negative in this case, and then positive in this case. I would have rewritten it as positive, then negative most of the time. But, you know, we rewrote it two different ways, and all we had to do was change the value of what was on the right side to kind of solve for this. And the reason why I mention that is because now we're going to get into the let's solve some absolute value equations part. So the observations we just made would indicate that absolute value equations often have two solutions. Often can have one, it would have to be 0, but they can make them true. And we say this following argument is valid. So we say if the absolute value equals C, okay, and I want to make an argument about C. We're saying C, this is basically saying that it's non-negative. That's what this statement is making. But C is some number that is not negative that the absolute value of this equals. Well, then we say, well, then if that's the case, then this statement, basically this is a formal way of saying it can be rewritten two ways. The first way, you'll notice that nothing changed except we dropped the absolute value bars. See it? See it? And then the second way, we still drop the absolute value bars on the left here, but we reset the right side to be negative, and then we say those were our solutions. Just like, you know, with the absolute value of x was equal to 8, what if we did 4? I would rewrite this two ways essentially. In our first way here, we're going to say x equals 4. And our second way, we're going to do this, 2 right there. We're going to say x still equals, but in this case, negative 4. So if that's the case, then what I want to do is practice essentially solving equations with absolute value. So we're gonna point some things out here. First of all, I'm going to write down some steps, which in this set of problems we're never going to have to do, but we say isolate the absolute value bars. And what I mean is if we had a statement like this, 2 times the absolute value of x minus 4 equals 5, we would actually have to divide both sides by 2 first. Okay, we have to get that out of the way so that we can get this in the first place, this x minus 4, the absolute value of that, equal to 2.5. Just to even get to be able to rewrite it. So isolate the absolute value bars. In this case, you notice that they're all isolated, you know, nothing around the absolute value bars. That being said, number 2 is we're going to rewrite two ways, okay? We say number 1, we'll call this letter A. We say don't change anything. So in our first way, we're not going to change anything. We say no abs value bars. Okay, we lose those. But we say the second way, we're going to leave the, and this stands for left-hand side, LHS in math. Left-hand side. Leave the left-hand side alone and change the right-hand side value to be negative. Okay. And then the last thing we want to address here is this, and this step 3 is solve each inequality individually. Okay. And in this case, I just realized that we're doing equations. So equation individually. So we're going to do these 3 here, starting with this. I'm going to go ahead and say that I used to write my work like this right here, actually. We'd say x plus 3 on the left is equal to 7. And we say rewriting this, we still have x plus 3 on the left, but in this case we have negative 7. And so the cool thing about solving absolute value equations that I get to point out to you today is this. When you solve these equations, and see on the left here we got x equals 4. And on the right-hand side, we say, well, I'm still subtracting 3 from both sides. And you know, the wonderful thing is because, well, that makes sense. You rewrote the same equation on the left twice. We say here are 2 solutions, and in terms of graphing them, hey, here's all we need to see. I suppose we have enough room that I could actually make 4 notch marks here. I could have just gone right, you know, and drawn a notch mark and called this 4. You would have had to have believed me. We say 4. We're going to put a dot on this, and I'm actually going to use all this coral color here, but we say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If this would have been past negative 10, man, I wouldn't have drawn dots. But we say these are the solutions, okay? Keep that in mind. When you make a graph, you are sketching in the solutions. That's what we're making, okay? So let's take a look at a couple more really quickly here. We say this one, again, we could rewrite it 2 different ways. 2x minus 3 is 1, but also 2x minus 3 is -1. And again, we're solving these the same way. So in this instance, you're going to see me do them all at once. This is up to you if you want to do them all at once. But we'd say in this case, we have 2x is equal to 1 plus 3 is 4. And we have 2x is equal to -1 plus 3 is 2. So now when we split all these out, we say divide by 2, divide by 2, divide by 2, divide by 2. We're going to get this. We get x equals 2 for this first one here. And for the second one, we're going to get x equals 1. So again, these are our solutions. We want to illustrate them. So we say here's 0, here's 1, and here's 2. We need a label. We'll color those in. And those are the solutions. Okay, and then last but not least, this one. Now again, I just want to make this comment. Just because it's absolute value does not give you permission to turn this positive again, okay? All we need to do right now is rewrite this two different ways. So we get -x plus 7 is equal to, let's see one thing really quickly here. This, I think I put it on there to catch people, but I shouldn't do that. I made it negative on purpose so we could say no solutions, okay? If it had been negative, we would say, well, the distance on something is never negative. So we would have said no solutions. But in this case, I'm going to go ahead and say, well, what if it were positive 12? We would have rewritten it as -x plus 7 is 12, and -x plus 7 equals -12 and solve this. Other way, we say subtract 7 straight across the board. 7's gone. And we get -x equals 12 minus 7 is 5. And we get -x equals -12 minus 7 is -19. So we'd say positive x is 19 and positive x is -5. So we'd say, in this case, look what I'm going to do here. I'm going to go left. I'm going to call this -5. I'm going to draw a dot there. And for 19, I'm going to go 1, 2, 3, 4. We're going to call this 20. And I'm going to say, hey, this guy right here, remember we label everything? We say, that's 19 because I said so. Okay? But that's how you deal with absolute value equations. Cheers.